Hi folks, this is question 7. It looks complicated here. All that's really happening is it uses this much silk to make its first web, and therefore it uses this much to make its second web. So therefore, to get how much extra it uses, we just have to do 37.8 take away 15.8. That gives 22. So it uses 22 extra. Okay, so 15.8 plus 22 gives me 37.8. And then for the other one, we just have to do 66 take away the 37.8 that we used already. And that gives you 28.2 when you subtract them. So all you really have to do is subtract there. The numbers A1, A2, A3 form an arithmetic sequence. Find an expression for A of n. So arithmetic is E of n is equal to a plus n minus 1d. That's in your log tables. T of n is equal to a is the first term. That's 15.8 plus n minus 1. The difference there is 6.2. You have to go to get from 15.8 to 22, you go up 6 point, sorry, what was it? Yeah, 6.2. And then to go from 22 to 28.2, you go 6.2 as well. So 6.2 is what you're multiplying there. So equals 15.8 plus 6.2n minus 6.2. And that is 6.2n plus 9.6, I think. Right, third part, a of 100. So a of 100 just means you put in 100. So 6.2 times 100 plus 9.6. And that will give you 629.6. So it looked the start of this question looked complicated, but doesn't seem too bad once you get into it. So it's all sequences. Next part, we have to use the Sn formula, and that's in our log tables. It's n over 2, 2a plus n minus 1d. You just copy it out, and then we're going to put in, now it's for Sn this time. So for a, the first term in Sn is 15.8. That's 15.8 plus n minus 1, and the difference in the Sn. So actually, sorry, I'm getting confused. It's not this Sn we're using. It's just what it's called. It's still the AN that we're using because the Sn, this thing isn't an arithmetic sequence anyway. Can't use that, so it's still going to be 6.2 that we put in. So it's still the AN that we're using. It's just the way they're wording it. And that's what we get. And if we multiply out everything here, it should give us what they want, hopefully. I'm just going to divide the 2 into both things. So that will give me n 15.8 plus, and then that would be 3.1 times n minus 1. I'm just dividing everything inside the brackets there by 2, just to get rid of that 2 there, because that's a bit awkward. Instead of multiplying in n over 2, it just makes it a little bit easier. Therefore, you're going to get what it is in the end. If you multiply the 3.1 by n, it's 3.1n. Multiply the 3.1 by minus 1, it's minus 3.1. And then you'll do 15.8 minus 3.1. And it'll give us the 12.7. And then you have to multiply in the n. So it's just algebra from there. But it gives us 3.1 n squared plus 12.7 n. That's all we have to do there. Right, so for this then, first of all, 10 meters, that's the same as 1000 centimeters. We're just multiplying by 100. So 3n squared plus 12.7n, that has to be greater than 1000. So the reason, because this is the total amount of silk, and they want the first one where it's greater than 1000. And then that's how we set it up. And if we bring the 1000 to the other side, it just gives us, sorry, so minus 1000 is greater than 0. And then it's minus b formula. So minus 12.7 plus or minus square root 12.7 squared minus 4 times 3 times minus 1000 all over 2 times 3. And when you put it in with a minus, you get minus 20.5. And then if you go back and put it in with a plus, you get 16.2. Now we're talking about a stage here, a stage, so stage K. Therefore, the minus doesn't make sense, so we can cancel that out. We always do that with sequences if we get stage minus whatever. And the other one then, because it's 16.2, but we want the first stage that it will be above 10 meters. So therefore, the first stage, you can't have stage 16.2, but stage 16 wouldn't be quite there. Okay, so stage 16 wouldn't have total length of silk more than 10 meters, so it has to be stage 17. So we just round up. So it's the first 17 is the first stage where the total length of silk is more than 10 meters. And for part B, it goes on to geometric sequences. So the first term in the sequence is 0.5 and the next one is 0.53. With geometric sequences, you have to each term is being multiplied by a number to get to the next one. So 0.5 is multiplied by some number to give you 0.53, and then that's multiplied by the same number to give you the next term, and the same number to get the next term, and so on. So if I do 0.53 divided by 0.5, that will give me what R is, what the common ratio is, and that's 1.06. Therefore, each term in the sequence is being multiplied by 1.06. So you're going to take 0.53 and multiply it by 1.06 to get to the next one, and so on. So we're just multiplying by 1.06 every time. And they want us to find the length of O3 here. Therefore, that's what you have to do. So you have to do 0.53 multiplied by 1.06, and it gives us 0.56. And because it says total length here, we're going to use the Sn of a geometric sequence. We're going to use that formula. Now, because it says total length here, we're going to use a 1 minus r to the n of 1 minus r. That's the Sn formula. And a is 0.5. 1 minus r is our 1.06. That's the power of n. So write an expression for n. So we don't know what n is. Over 1 minus 1.06. And I don't think there's much you can do with that then. You could simplify the bottom there if you want, but it doesn't tell you to, it just says to write an expression for n. And the last part, it has exactly 18 orbitals. Therefore, so it's the first k elapsed. Therefore, n is equal to 18k, okay, because it has 18 orbitals. So if we just put that in, then it's just 0.5 1 minus 1.06 to the power of 18k. So it's looking a bit messy now, but we don't have to do anything with it. So at the bottom there, you could simplify it into minus uh, 0.06 if you want, but probably don't need to either. So that's all you can do. It's just give it, write the expression in k, so it's in k. So that's it.